talking to you today from a human factors perspective. So I think that counts, along with Diane, as being the second person in the room here who's not technical. Human factors perspective means that I care about what people like you do when you're working with complex technologies. I'd like to design tools to help you do the work that you need to do and to make sure those tools are really useful for the ways you value doing your work. So I want to talk to you today about a project that I'm working on. We're in the initial stages. I'm working with Lucent Technologies, and it's aimed at all kinds of networks. I think that's really important to say, seeing as we've heard so much about the difference between internet and telecommunications. Our goal is to support advanced troubleshooting, especially for end-to-end performance in hybrid networks much more usefully than people can do it right now. We've conceptualized giving advanced troubleshooters workspaces for integrating the really hard parts of problem solving, and we've conceptualized a standalone open source framework which serves as a workspace, which I'll talk about a little bit later. Right now we're in the first stage of this. We're not at the framework stage. And the first stage for that, especially from a human factors point of view, is to discover what troubleshooters actually do when they tackle complex problems and what support they need. That might mean many of you, and you are of supreme interest to us in our project. We know that there are a lot of end-to-end initiatives going on right now to help in complex troubleshooting, and things that are looking into how to gather all the data that are needed, how to create databases, how to have these additional metrics that we're hearing about right now, how to have good tools. What we're looking at is beyond that, how do people put all that together to do work that doesn't really have any structure that's a preset, predefined, rule-driven structure. And to gather that information, we're doing observations, we're talking to people and having interviews, and we're analyzing transcripts of troubleshooting conversations, whether through email or some other trouble tickets and all those kinds of different things that we can look at. What is a complex problem? Complex problem is anything that's unfamiliar and unanticipated. It doesn't have a formulaic way of solving it. It's things like intermittent faults, or something's happening that shouldn't be, or entangled faults that require end-to-end performance analysis. I'll try to give a concrete example which might be familiar to many of you that represents a complex problem. In a video conference with poor transmission, the video transmission equipment showed that a significant packet loss was occurring, but the network support engineer couldn't get similar readings. Ping showed there was no packet loss, and an iPerf test showed only 1%. The support engineer enlisted the help of the end-to-end performance group, and together they looked at the path. One of the biggest problems was to find appropriate test points to represent the path. In fact, the whole group spent hours getting to just the right person and finding just the right path. Once they did, they ran tests and found that the 1% loss was occurring only in one direction, out from the conference site, which was the Gigapop, to the remote participants at the universities. The engineers split the path and found loss from the backbone to the Gigapop. They then studied the Gigapop end of the path closely. They found that the router interfaces from the backbone to the Gigapop showed 1% error since the counters were set 2 weeks earlier. At this point, the support specialist called the backbone NOC and found that there was a known problem with some optical equipment that could not be fixed immediately. No one had told the other groups about this problem. There wasn't any means for doing so. Nor did they think that a transmission of any size would be occurring that would be adversely affected by the faulty optical gear. In the meantime, the video cast was a failure. At times, it lost audio and video signals, and the transmission quality was poor the whole time through. It took all day to track down the problem, finding it only after the video netcast was long over. So, what were the pain points of this investigation? They needed to look for false positives. They needed a reality check. The measures that they were getting were not the same as the quality of the transmission that was going on. There was insufficient data. They didn't have all the information that they needed to solve the problem. They needed to make their best effort in solving this butterfly effect problem, where problems in one part of the network were affecting the other part. And there was a lot of trouble with communication across the segments and the organizations. We're really interested in story after story of this, and we've gathered many cases that show even more complex problems than this. One was very similar, but instead of a known problem, it was an unknown problem, so that an ATM switch was out and nobody had any idea what was wrong and what had done it. You could fix that problem, but the root cause analysis then took many, many hours to track down what the real problem was. We even have more complex examples, such as one in which a calls and a voice over IP were completing, but parties weren't hearing each other. And this happened only 1 every 1,000 calls, and it happened over many, many weeks. All parts of the system were reporting healthy. The engineer who was in charge of it decided that he would bring in some ad hoc data from the billing records to see which calls had short hold times, figuring that he could find out where the problem was that way. So he wanted to correlate those with data on each part of the system, from the phone adapters, the router ports, the ISP subnets. But this was complicated by unique IDs changing as the calls traversed the system. What was hard for this analyst, this network engineer, was to see patterns because of the huge number of calls and the changing identifiers. So even after when all the data are available, there's this huge problem of how to put it together, how to see non-obvious patterns, and how to display data for certain types of problems and certain types of analysis so that people can really understand what they need to know. This is what we're really looking at, not just what data are needed, not just what knowledge bases are needed, not just how to integrate data across the system, but how do you mix that with the human intelligence that's required for non-standard problems and augment that intelligence with the tools that we have and not try to automatically replace it, because you can't in complex problem solving. So what's our focus for support? We want to try to see what people's integrated experiences are and give them integrated support for that. We've roughed out a standalone framework that needs to be filled in once we find out what people's real needs and practices and activities are. We talk about bringing data in and helping to parse it and sync it up so that you can analyze data from across diverse sources that's oftenly incompatibly formatted. From there, it would feed into a database, and this would feed into a visualization engine, which would then know the kinds of data that need to be looked at together, the best graphs for doing that, and display those so that people can see non-obvious patterns. There would be a place in this framework for collaborative activity and sharing and collaborative problem solving as well. Right now, as I said, we're on the first step, which is just the user modeling, and that's really trying to get just the right level of analysis. I've talked about designers know how to talk about the low level of analysis, the tests that need to be run, and doing segment by segment analysis. Designers also know pretty high level analysis, which is the kind of aggregates that are needed, large level displays that are needed, or best practices databases. But what we're looking at is the hardest to define, which is that mid-level, where we're trying to see what are people's integrated moves as they're moving through complex problems to get them from here to there, and what do they need in terms of a kind of mixed initiative between machines and humans to really augment human intelligence. That kind of thing would address these reality checks, help with decision about trade-offs, getting accessible data, getting available data, and recognizing non-obvious patterns. Our next step is to continue to learn from support engineers what some of these mid-level challenges are in problem solving, and then turn our models into an open source framework and workspace that can serve as a problem solving workspace for these complex troubleshooting events. We're also looking at artifacts like email exchanges and trouble tickets, and seeing what we can find from that in terms of the ways that problem solving goes on. And one of the most important things that we found from the ones that we've looked at so far by stretching them out, and I don't think you can read that, but what you see up there is stretching out some of these conversations of where people look, what they needed to do the problem solving better. And at the very front, what we see are linearly, those are prerequisites. Anything that is to the left needs to be in place before you can do the problem solving steps to the right. And in that purple group, those things are all things that are highly political. Getting application developers to develop in certain ways, getting people to share information, getting people to feel responsible for writing certain algorithms. And so we found that this kind of political nature is one of the most important things to get in place. And we've also found that it's a very difficult thing to do when we're talking in a decentralized, distributed world. So, as I said, we're trying to lead this to a framework, and any comments or help or stories that you can share, I'd really appreciate it. Oh, there's a BOF afterwards where, it's at 9 o'clock tonight, where I'll be there and would love to talk to people about some of their stories. No, I don't have anything on the next slide.
Okay. If you want to get a hold of her, why don't you send to the NANOG list your email address?
Okay.
She'll send to the list the NANOG, and she'll give you an email address. She'd really appreciate stories. It really would help them look at troubleshooting in the way it occurs.